So let's try one more example, another n-way selection example. So just real simple, we're going to take two arguments and we're going to call it, we'll call this compare. We're going to take x and y as arguments and we're going to do a con statement and we're just going to compare x and y. And if x is greater than y, we'll say greater. If x is less than y, we'll say less than. And if x is equal to y, we'll say equal. So let's try that. So greater than xy. Now, if you put a single quote, you create something that's called an atom. So I'm going to put a single quote here and I'm going to say greater. I'll say x is greater than y. And I'll do a less than xy. X is less than y. And I'm not sure that's going to work, actually, but we'll try it anyway. So now we could say equals here, or we could say else. So I think I'm going to say else. X is equal to y. I went off the reservation here a little bit by not following my notes exactly. So let's see what happens. So let me go over here and click run. Yeah, I didn't like that. Okay. There is a way to do strings. I don't know if this does it. Try that as an experiment. If this doesn't work, I've got a simple solution here. Oh yeah, that didn't work either. Okay, so we'll just change this to greater. Less and equal. Okay, try that. I think. Okay, cool. So now if we do compare and we say, let's say x is 5 and y is 1, what do you expect the output to be? It should say greater, which it does. Let's compare 1 and 5. So x is 1 and y is 5. It's going to say less. And if x is 1 and y is 1, it's going to say equal. So that's another example of an n-way selection. All right, now I want to talk about lists and functions. All right, the only data type that we've looked at so far is the data type of an integer, but it's possible to work with other data types, and one of the most common data types that you're going to work with in Scheme are lists. There are no other data types in Scheme. You either have some basic numeric types, a basic string type, or you have lists, and that's it. So how do you define a list? Let's try it. So let's try parens. So let's define a list as being, there's a simple list, A. Okay, that's a problem. If we use parens by themselves to define a list, what's going to happen is that Scheme is going to try to interpret the value of A. It's going to treat it as an expression. So we can stop Scheme from doing that by putting a single quote in front of the A. Whoops. sorry, single quote in front of the A like that. All right, so now it's not going to be evaluated. When we put it in parens, it means evaluate that. But all right, now if we want multiple items in a list, we could try to do this A, B, C. That's not going to work out so great either because we're trying once again to evaluate things in the expression between the parens. So, and it's saying A, the function A is not defined. Okay, that makes sense, right? Because if we're doing prefix notation, it would be here's parameter 1, here's parameter 2, and here's the function that's supposed to be executed using these two parameters as arguments. All right, so to define a list, what we're going to do is use a single quote, open paren, and then we're going to say A, B, C. This is a shorthand notation that Scheme knows about. And this basically says, make A, B, and C atoms in a list. So over here, this A with a single quote is called an atom. This is a shorthand notation that says, take the things in parentheses, don't treat them as arguments or as parameters, and turn them into a list. So A, B, and C are now elements of a list. Okay, cool. Now once you have a list, of course, there are things that you want to do with the list. So let me just put this up in the comments here. Defining an atom, which is something you don't interpret, evaluate. All right, so here's an example of defining an atom, A. Now A is an atom. All right, defining a list of atoms. You're going to do this, A, B, C. All right, I think we can also, just as an experiment, list A, B, B, C. Yeah, that's another way that you can do the same thing. But the single quote ABC in parens, that's a shorthand notation for defining a list. All right, so what we would like to be able to do now once we have the list is do some manipulation of the list. All right, so one of the things you probably want to do is you want to return the first thing in the list. All right, so first, and here's my list, A, B, C. Now, what do you think first is going to do? Well, it's going to get the first thing in the list, and the first thing in the list is A. So we'll get A. What if I did this? First, AB, CD. So what do you think the first thing in the list is going to be this time? Do you think it's going to be A? Is it going to be AB? Is it going to be an error? It's AB. So the atom, the first item in the list is the atom AB. All right, what would happen if I did this? First A. Well, that's an error because A is not a list. A is just an atom. So how could we correct that? First A. There we go. So now we had a list that just contained A. We took the first thing in the list. What do you think this is going to do? First, and then we have an empty list. That also generates an error because we're trying to take the first element out of an empty list, which we don't have. Now, there's another way. Let's see if this works. Yeah, there's another name or alias for first, and that's called car. So if we go back in time to the beginnings of the development of the language, Lisp, car means get me the first element in the list. But Scheme came along and said, car, that's not exactly the most intuitive name for this function, which gets you the first item in a list. So we're going to use first. All right, So first element, let's do a little semicolon here. Get some spacing in here. First element in a list. First a Okay, well, if we can get the first element in the list, of course, what's the other thing we might want to do? Well, we want to get the rest of the list, right? If we pull the first element out of the list, we'd like to get the rest of the list with that first element removed. So there is a get the rest of the list after first element. Okay, and the way we do that is we return something called use something called rest, the function rest. So rest A, B, C returns everything but the first element. So we're going to get the list B, C. All right, what do you think this is going to return? It's going to return C and D. What about rest A? That's an error because it expected a list. What about rest? So we could fix that. How about this, rest A? What do you think that's going to return? Is it an error or is it going to return something? So it's everything but with A removed, which is the empty list. Okay, so let's write that up here. Rest A, B, C returns BC, the list BC. Okay, so let's try an exercise here, okay? I want you to write a function which returns the second element of a list. All right, so right here in the definitions window, I'd like you to write me a function that returns the second element of a list. And just to show you what I mean, let's give an example of what it would look like. If I said de, that's French for two, de A, B, C, what de A, B, C is going to do is it's going to return B. All right, so give it a shot and see if you can write that function. Hit pause and give it a shot. Okay, I'm assuming that you are unpausing and you've made an attempt. So I'm going to write my function here, define de, and it takes in L. I don't want to say list because list is a defined word. So L is my parameter. And the way L is defined is I need to get the rest of the list. All right. If I get the rest of the list, that's going to give me BC. But I want the first element of the rest of the list. I want B. So first of rest of list. Okay. So I think that makes sense. L is ABC. I'm taking the rest of L. That's going to give me BC. And I'm taking the first of the rest of L, the first of BC, which is going to give me B. Well, let's try it. All right, de A, B, C. Yep, it gives me B. Cool. So one of the things that we might want to do is we might want to construct a list. All right, so we've looked at two ways of doing that. Defining a list of atoms, A, B, C up here. I'm just going to add this. We can also say list A, B, C. That would also give us a list of atoms. But there's another way that we might want to construct a list, and that is, what if we had an atom A and we wanted to insert that atom. Oh, maybe I'll write it up here in the comments. How would we insert an atom into a list? So what I mean is, let's say we have A and we have an empty list. How can we get that to give us the list, the empty list with A inserted in it? And the answer is you use cons. So if you say cons A and the empty list, that is going to give you A. So con stands for construct. So let's try it over here. Cons A, and now we have a list containing A. All right, let's do a few more constructions here. Cons A, and we have the list BC. All right, that's cool. How about this? Cons empty list, and we have the list A, B. What do you think is going to happen if I do that? Well, we get a list that contains another list, the empty list, and A and B in that list. What happens if we do this? Cons A, B, and we have the list C, D. Oops, I did con there, not cons. So now we have a list inside a list. So we have a list that contains the list AB, and then also an atom C and an atom B. So a list inside of a list. Let's just do one more list. Apple, orange, grape. Delicious. Apple, orange, grape. Okay, what if we do this? Cons, we'll insert some more fruit. How about a pineapple? Pineapple. And we're going to insert it into this list of apple, orange, grape. So now we have pineapple, apple, orange, grape. Okay. Now, there are some very useful predicate functions for atoms and lists. Because what we've been working with so far is some operations that let us manipulate lists, build lists, extract elements from lists, get basically sublists from lists, and also insert atoms into a list. But we also like to find out things about the list, right? Ask questions, do list analysis. So the first predicate function that we'd probably want to do is equal. So this returns true if arguments are equal and false otherwise. All right, so let's compare. Let's do a couple of examples of equal. So we'll do one example here in the comments, and then we'll we'll do some other interesting ones. So equal AB, oops, sorry, AB, AB. So that's going to return true. All right, so let's do an example down. We'll do a bunch of examples down here. So equal list A, B, and compare that to the list A, B. Are those lists equal? Yeah, they're equal. We can also compare atoms if we want. So equal A, A. Oops, I didn't do that correctly. Equal A, A. All right. Is this equal A and A? Are those two equal? So take a moment to think about that. Let's try it. We'll hit pause if you want to think about it. And I'm going to try it now. So it's false. Why? Well, A is an atom, and this is a list containing the atom A. So they are not equal, that's for sure. Okay. All right. List, question mark. This returns true if arguments, if parameter, if argument is a list, false, otherwise. All right, so let's try that. Let's try an example in the comments and then we'll do it for real. So list, and here's a list containing A, B, and C. This is going to return true. All right, so let's do that. Oops, list question mark. Okay, so list question mark A, B, C. Yep, that's a list. How about list question mark just A, the atom A? And that's going to return false. Okay, so what else might be useful? Empty. So returns true if list is empty. False. False otherwise. All right, so let's try a couple examples of that. Well, yeah, let's spell otherwise correctly. And a comment example, empty, question mark. True. All right, so let's try that down here. Empty. All right, that's going to return true. And empty. What do you think that will return? That is not a list, so it's going to return false. Empty. How about this? Empty first. All right, so we're saying empty of first of this list. Well, the first thing in this list actually is an empty list, so true. How about this? Empty rest A. What about this? Well, let's see. Rest of A is going to remove A because A is the first thing in the list, and we'll be left with the empty list. So empty of rest of A should be returned true. And it does. Fantastic. Okay. We're ready to start a program that's fairly sophisticated. So we've been doing kind of little functions to get an idea of sort of the basic constructs of the language. The language has very simple syntax. You can work with numeric types, atoms, and lists. And we have some really simple ways of doing operations on numeric types, comparisons using numeric types, and some real basic operations on lists as well. With just this basic stuff, we can do all kinds of interesting programs.